Okay guys, so today we're going to look at the molar stuff again, the mole conversions. You did molar mass yesterday. The ones that I've seen so far look really good. So great job, and it's really easy, so please go and give that a good shot. Today we're going to look at mole-gram atom conversions. So I hope you got some paper ready, and let's go ahead and get going. Okay, so this is a known 1 mole of anything equals the molar mass of that element or compound. Okay, so then how could we determine the number of moles of 36 grams of water? Okay, well we did the molar mass of water yesterday. I'll do it again just so that we have it here. You list your elements. How many hydrogens we have? 2. How many oxygens we have? 1. The mass of 1 hydrogen is 1. The mass of 1 oxygen is 16. So this is 16. This is 2. And so that gives us a molar mass of 18 grams in each mole. Okay, or 18 atomic mass units. So if we have 36 grams of water, and we know that there are 18 grams in every 1 mole, we can say 18 grams of water in 1 mole of water. Okay, this is it's like a conversion chart. This is called factor label. This is called dimensional analysis. That's probably the most common thing you'll hear this called, is dimensional analysis, where things that you put like this together have to be equal. Okay, and each of them is a factor that you use to convert from one unit to another unit. Okay, so in this case, this works just like anything else in math. If you have something on the top and the matching thing on the bottom, they're going to cancel. So grams of water, those cancel. So then our units we're left with are moles of water, which is what it asks for, the number of moles. Okay, so then we just need to do this math. 36 divided by 18 would be 2 moles of water. Okay, now if you don't have this written down, go ahead and pause it so you can get it written down. Okay, here are 2 problems I would like for you to try. So I need you to pause me, I need you to write them down, I need you to try them, and then unpause me and I'll work them. So go ahead and pause it. Okay, so again we want number of moles of 22 grams of CO2. So we're starting with 22 grams of CO2. So the thing we want to cancel is what we're going to put in the bottom, which will be grams of CO2, and that's going to match moles of CO2. Okay? If you need to remember, there's 1 carbon times 12, there's 2 oxygens times 16. So this is 12, this is 32. That gives us 44 grams in every 1 mole. So 44 grams in 1 mole. Okay, so grams CO2 cancels. We're left with moles CO2. So 22 divided by 44, that's going to give us a half of a mole, or 0.5. Okay? Okay, if you didn't get that one on your own, you can pause and you can go ahead and try the other problem, which is here. Okay, so how would we determine the number of grams? So this is a different question because we're given moles. Okay, so we're still going to put what we start with on top, 6 moles C6H12O6. Okay, but this time those moles are going to go on the bottom because we need them to cancel. And the grams C6H12O6 will be on top. Okay, if we need to remember that molar mass, you have 6 carbons, 12 hydrogens, and 6 oxygens, times 16, times 1, times 12, that's 72, that's 12, that's 96, and that gives you a total of 180 grams in 1 mole. So this is 1 mole, this is 180 grams. Okay, so moles cancels. So we solve 6 times 180, that should be 720 grams. C6H12O6. Okay, and that is as hard as it gets. Okay, on grams to moles. So if you've got questions, post your questions. The next conversion we're going to look at uses this known. Okay, 1 mole equals 6.02 times 10 to the 23rd atoms. This number is called Avogadro's number. Okay, and this is a number that we use. So this is a huge number, right? Because it's 602 and then 21 more zeros to take this scientific notation and expand it out. So this is a number we use to represent the number of atoms that are in 1 mole of anything. So it doesn't matter what it's a mole of, it always has the same number of atoms. Okay, the grams is based off of the molar mass, but the atoms is the same no matter what it is. Okay, so we're going to do dimensional analysis again. We're going to start with what we're given. 2 moles H2O. Okay, and then our conversion factor, 1 mole, in this case of H2O, equals 6.02 times 10 to the 23rd atoms. Okay, so the moles H2O and the moles H2O cancel, and you should get 1.204 times 10 to the 24th atoms H2O. Okay, now let's talk about, this is where I hate that we're not together in the same room. Okay, I wish I had a calculator emulator. Let me see if I can find one. I'm going to pause this. Okay, so I've got an emulator going, so let me show you this in the calculator. Okay, so you would do 2 and then times, and then you do the 6.02. Now, this is where you want to let your calculator work for you and not against you. Okay, you see this button right here, times 10 to the x? If you hit that, that puts times 10 to the in the calculator. Okay, now, I'll tell you, on some of your calculators, it may be a button that says EE. Let me finish this and I'm going to find some images to show you. Okay, so 2 times 6.02 times 10 to the 23rd. And then you're going to execute that. And so here's your answer. So when you record that, you should write 1.204 times 10 to the 24th. It doesn't put times 10 in the answer typically. Typically it's going to do this. It's going to say E24. Okay. Okay, this is a very common calculator. Okay, a lot of you may have this one. Now, to get the times 10 to the on this calculator, you're going to use this button right here. Okay, let me do this, and then this, and then I can get something to write with. Okay, this button right here, that EE button. And when you press that, it's going to put on the screen 1E, and then you just enter your exponent. Okay, now there are other ways to do it. You could press times and you could type in 10, and then you could use your this caret button and add the 23. But the thing is remember, your calculator does not understand order of operations. And so by using the EE button, you are forcing it to treat that thing, that 6.02 times 10 to the 23rd, as a unit. Okay, and so it's making it solve that and then put it with whatever. Okay, some of your newer calculators, this is a common calculator as well. Okay, it's got the EE button. Sometimes the EE button is a second function. I'm trying to find one that has it as the second function. So that you have to press second and then press EE. Some of these are hard to read. I don't see it on this one at all, and that's just crazy. It's here. I just got, oh, here it is. It's an EE. Maybe it's on the graphing calculator. That it's a second function. I know it is. Oh, right here it is. It's a second function on the period. That's EE right there. Okay, I know it's hard to see on this screen. See if it's better there. It is. Okay, so on the comma, it's a second function. So you would have to hit second and then this button to get the EE function. Okay, some of you may have Casios. It looks a little different on a Casio, so let's Casion. This is one that I have in my classroom. It has a times 10 to the x. Now its location, it's down at the bottom instead of where on TI it was up here. Okay, so you need to figure out where it's at on your calculator. Again, it's down here at the bottom. At the bottom. Now, if you have a calculator like this, it's not going to be able to do it. Okay? Hopefully you do have a calculator that you're using. iPhone calculator sideways. So if you're using the calculator in your phone, okay, I feel like you do have to turn it sideways to get to those extra functions. Okay, and mine looks most like this one, I guess. Okay, and so it's the EE button right here. Okay, just like you would, that's a different one. It's right there, the EE button. Okay, so I do want you doing this stuff on a real calculator though, because that's what you'll have to use when you do your AP test next year. So it's important to practice the way you're going to have to perform. Okay, let's see if I can get, here we go, let's go back here. Okay, so that's your answer. So I want you to try these two, so pause me, write them down, try them. Hopefully you're really pausing me. Hopefully you're back and you're like, go on, Miss Garrison. Okay, so let's work these two out. So, how many atoms, let's get a pen, how many atoms, that's our question, would be in 0.5 moles of CO2? So that's what we're starting with, is 0.5 moles CO2. That's a big O. It just looks like a little O. Do our dimensional analysis. So we know that 1 mole CO2 has how many atoms? 6.02 times 10 to the 23rd atoms. So solve that. 0.5 times 6.02, that's going to give us 3.01 times 10 to the 23rd atoms. Okay? You still need to write. Just pause it. How many atoms would be in 720 grams? Okay, now, everything else we've done has been between moles and atoms. So let's think about this. We know how to get from grams to moles, and we know how to get from moles to atoms, so we can just do it all at the same time. So you start with 720 grams C6H12O6. Okay, we know that the molar mass of that is 180 grams in 1 mole. And then we know that 1 mole of anything has 6.02 times 10 to the 23rd atoms. Okay, so then if we go through and we look at our units, grams cancels, moles cancels, so we're left with the units we want, which is atoms. Okay, so when you get multiple things in your dimensional analysis table, you just multiply everything on the top and divide by everything on the bottom. Okay, so this is going to be, I don't already have this worked and I apologize. I think it's 3.6 times 10 to the 24th. I'm going to punch it in though, make sure. Oh, I'm wrong. It's 2.4. .408. Okay? Questions, post them. This is one of those that some of you may need more practice than others. So read the directions carefully on the assignment to see how many you'll need to do. And that is the end for today. So I will talk to you soon.